Okay, good afternoon, everyone. Let us start today's session. In the previous lecture session, I had explained you about, we had seen this microprogram example and we had seen how does mapping work. Why do we need to do mapping? How is mapping done between main memory and control memory? Okay, in the previous session, we had seen that every instruction that is fetched from the main memory has a 4-bit opcode. Okay, so this opcode which we were using, which we were having in our main memory instruction format, this opcode is of 4 bits. Now, opcode, if I have a 4-bit opcode, there are total 2 raised to 4 operations possible. 2 raised to 4 means there are total 16 operations possible, and for each and every operation we have a specific microprogram in the control memory. So if I want to see where is the microprogram for 0000, which is add operation located, I'll have to carry out mapping, as this is a 4-bit operand and the address of my control memory is of 7 bits. Okay, so what did we do in the previous class? We saw that how to carry out mapping from the main memory to the control memory depending upon how many control words a particular microprogram occupies in the control memory. So if it is a 4-bit 4 control word, if a particular operation occupies 4 control word, we will be appending 2 zeros at the end. So if it occupies 8 control words, we will be appending 3 bits, 3 zeros at the end to make it 8. Okay, so depending upon that, we had seen that how to do mapping. Now, apart from that, we also saw the micro instruction format, which is of 20 bits, out of which the first three fields are your micro operations F1, F2 and F3. Each of these would be of 3 bits, F1, F2, F3. Okay, 3 bits each. After that, we have a field for CD. CD occupies 2 bits. Then we have BR. BR occupies 2 bits. And last is your address of your micro instruction. Okay, that is the address operand. So total 20 bits. This address would be of 7 bits. So this F1, F2, F3 can be from these 3 tables. Right? For 3 bits each, F1, F2, F3. I can carry out 3 micro operations simultaneously. And if you don't want to execute 3 micro operations simultaneously, you can keep any one of them to be no operation. So 000 in each of the case indicates no operation. I don't want to carry out micro operation for that particular pool. Okay, so this is how a particular micro instruction is written. So this is already done. Now let us move on to the next part.
This meeting is being recorded.
Okay, so now let us see the next topic. Okay, so now let us see how to write symbolic microprograms. Okay, as I told you that I have a control memory of size 128 cross 20, which is 2 raised to 7 cross 20. In this, we say that for each and every instruction, I have a microprogram written. So for add, then I have, my microprogram starts from location 0 and it will end at location 3. Similarly, my next instruction is branch. For branch, again, the program will start from 4 to 7. It will occupy 4 control words, 1, 2, 3 and 4. Then from location 8 to 11, I have store. Similarly, 12 to 15, I have exchange. So out of the 16 operations, we had 4-bit control word, 4-bit opcode, 2 raised to 4 is 16 operations possible. So out of 16 opcode, we will be seeing these 4 over here, but So can you tell me total how many control words would be occupied in our control memory for writing this microprograms for all these operations? 16 into 4. So 64 control words would be occupied for microprograms in my control memory. So my control memory is having how many words? 128 words, out of which 0 to 63 we are using for microprograms for each of these operations. So remaining 64 to 127 are used for common functions. They are used for common functions. Whichever common functions which are used by all of these micro operations, micro instructions, you will be writing those functions over here, okay, in this location. And suppose if you see, if I say that I have an instruction which cannot get completed in 4 control words, I'll need 6 control words for it. So what we will do is we'll write first 4 control words over here. First we'll be using first 4 control words for writing 4 micro instructions over here, and remaining 2 will be using it in the common area. Okay, so this is how your control memory is organized. Now let us talk about writing microprograms. First of all, when am writing a microprogram, it consists of different fields. Okay, so if I talk of a microprogram, first thing that we write, we start off with our microprogram is a label. Okay, we will make a label. Suppose I want to create a microprogram for AND. So what did I do is I made a label called AND. This is how we make label. You all have seen that for any go-to and all which we used in programming, right? We're making labels like this. The name of the label can be anything. So here, the first part of your microprogram, you'll be starting your microprogram with a label. Suppose I made a label AND over here. The next field is your micro operations. Micro operations. So you have one micro operation from F1, one from F2, one from F3. अगर आपको तीनों use नहीं करने हैं, you can write any one micro operation over here. Okay, so next field to be written in your microprogram would be your micro operation. It can contain any micro operation from any of these 3 pools, F1, F2 and F3. Okay, now you cannot use 2 micro operations from F1. Any one micro operation from F1 pool is allowed. Similarly, any one micro operation from F2 pool is allowed. Okay, after that the next field would be CD. CD has 4 values. Which are the 4 values? U is unconditional jump. Then you are checking the value of I. If your CD stands for condition. If your indirect bit is 1, then carry out branching. U indicates that unconditionally true. So for when U is written, branching has to be done. Okay, so U, I, then we have S is for sign bit and Z is for 0 bit. So what would be the next field over here? CD. It will have any one of these 4 values. You cannot have any other value other than these 4. Okay, so suppose I write U over here. Then comes BR. BR is my branching. It again has 4 values. Which are the 4 values? First is jump, second is call, third is return, and fourth is map. So the next field over here would be either of these 4. Suppose I write jump. Okay, so this is, see what I am doing is I am forming a micro instruction over here. What is a micro program? It consists of several micro instructions. What is a micro instruction? It consists of several micro operations, right? So next field is BR. This BR is followed by the address field AD. Okay, this AD can have again different values. It can be the symbolic address where you want to, whatever you want to appear in the label. Like suppose I want to jump to a symbolic address. Suppose I have written like this, jump L1. Okay, so what would it do? It would jump to this location, L1. What is L1? L1 is a label. It can be any address written over, there can be any address written over here. Like jump to 2000. So 2000 is an address here, so it will jump to that location. Suppose you want to move to the next line, unconditional move to the next line. So that would be jump next. When you write any xt next, by default, it would point to the next address in sequence. Okay, so this address field would be the last part. After jump, you write address field. So whenever you have written in your BR field, if return and map are written, Okay, in your BR field, if you have written RET or MAP, in this case, your AD field will be blank. You don't have to write anything besides your BR if your BR is of one of these, either return or map, because you know that when return is written, the address would directly come from the subroutine register. Okay, so you don't need an address over here on the right hand side of BR. Fine. So this is how a particular micro instruction is written. This thing would be more clear to you once we start writing microprograms and you see the examples. Okay, so now first of all, let us write the common routine. As I told you, you will need some of the functions are common to all the microprograms. So first is fetch. The first task that I need to do is fetch a particular instruction from memory. Okay, so you all know how to write register reference instruction for fetch routine. First of all, what will I have to do is, if I want to fetch any instruction, I'll have to transfer the content of program counter to address register, and then from address register, I'll have my memory address. I know from which location I'll have to fetch the instruction. So what would be the next instruction? M of AR to DR. If you look at your basic computer, we will transferring the data from M of AR to IR, instruction register. But here in the microprogram example which we are using, only memory, whatever we are reading from memory goes into DR, and whatever we are writing into memory, that comes from DR. Okay, so we have only two connections, memory to DR, DR to memory. So whatever instruction is fetched would be stored to DR. And simultaneously what we will do is, we will increment the value of PC by PC plus 1. It means we are making PC ready for the next instruction. The next task is what? Decoding. Here what we will do is, in AR, this is your AR, what are we doing? We are writing, we are mapping the 0 to 10th bit of your DR. If you remember, what will we get from DR? A 16-bit instruction, out of which 0 to 11 was your address, 12 to 14 was your opcode, and the 15th bit was your indirect bit. Okay, so what we are doing is, here 0 to 10 of DR is transferred to AR, this part. Then what will go to the control memory? CAR is my control address register. So for control address register, what we will do is mapping. इसका mapping करेंगे. This is a 4-bit opcode. So my control address register would be of 7 bits. So what we'll do is, we'll convert this 4 bits to 7 bits by appending 2 zeros over here and 1 zero over here. So what we will write, in my CAR, second to 5th bit, this is 0, 1, 2, 3, 4, 5, 6. So 2 to 5 bits के अंदर what we will transfer? DR के 11 to 14. Okay, and in CAR's 0, 1 and 6th bit, 0, 1 and 6th bit, what are we doing? We are simply transferring 0. So this thing takes place, this is taking place after the instruction is fetched. In our basic computer, we were having a decode instruction, but here this thing is included in the fetch part itself. Okay, whenever you are fetching an instruction, the instruction is fetched into DR. It is then decomposed, it is then divided into different parts and accordingly transferred to AR and CAR. Okay, so this is my register reference instructions. These are my register reference instructions for fetch routine. Now let us try to convert it to microprogram. Okay, so as we know that, how do we write the microprogram? First part is label. So I am writing the microprogram for fetch. So what did we do? We first wrote the label fetch. Now, before writing a microprogram, one more thing is important. You also need to tell that at which location in your control memory is your fetch written. As I told you, 0 to 127 are reserved for your microprograms of particular instructions. Fetch is a common subroutine. Sorry, 0 to 63. 0 to 63 are reserved for that. So fetch is a common subroutine, so it should be written in the lower part. And where will it start from? From location 64. So what would be the origin of this microprogram? It would be 64. So before you start writing any microprogram, specify where would this microprogram be stored in the control memory. Okay, as we told that for 0 to 63 are reserved. So fetch is a function, fetch is an instruction which would be used by, fetch is a microprogram which would be used by all the above microprograms. So we made it in the common section and its origin would be 64. Okay, now what was the first step here in fetch? What we were doing? PC to AR. Look at our F1, F2, F3. Do we have any micro operation called PC to AR? Yes, we have. It is in which pool? F1. Okay, so we will directly use this PCTAR, which would transfer the content of PC to AR. Okay, so we know that the first part is when we write in your program, after your symbol, after your label, we'll be writing the micro operation. Okay, so here what will we write? PCTAR. Now what we need to do is, after PCTAR, we need to read the content of we need to read the instruction and store it to DR. हमने क्या लिखा था? M of AR to DR लिखा था, right? So what I need to do is, after I get the value of AR, after I get the value of my effective address in AR, I'll jump to the next. So what we will write? You jump next. What does you mean? Unconditional. क्या करना है? Unconditional मुझे jump करना है. कहाँ करना है? To the next location. Okay, so PCTAR, you jump next. Now what we will do is, we'll write the read part. Read again is in your F2. Read is written in your F2. Okay, so we are directly using this micro operation read. What will read micro operation do? Read micro operation will transfer M of AR to DR. And simultaneously, I also want to increment my PC. So what is my PC? Increment PC is in F3. So can I write it together? Read is in F2, INC PC is in F3. So what did we do? We wrote these two micro operations together. After that, you jump next. Next comes whatever instruction is received in DR, what we will do is DR to AR. So 0 to 11th bit of AR would be transferred to DR. Okay, and then U and map. Do you remember what do we do in map? When we studied DR, mapping indicates all these things. ये जो हमने इधर लिखा ना, this thing was written in map. Let me show it to you. Look over here, map. What are we doing in map? Opcode is transferred to CAR of 225 and CAR of 016 will have 0. Okay, so this is what the mapping procedure that we did. So apart from DR to this one, apart from DR to AR will transfer the 0 to 11th bit and mapping would populate the value of your CAR. So this is how and we studied that whenever we have a map or return, don't write the address part. So this is your microprogram for fetch. Was it simple? Instruction is fetched and then it's also decoded. Clear? Now let us see one more function. Okay, this thing can be written. I'll show it to you in the textbook itself. This is a symbolic microprogram. Similarly, we can convert it to binary microprogram, where we'll be writing the binary values of all these. PC to AR is 110. So we'll write 110 here instead of PC to AR. Okay, so entire microprogram is written in binary form. I'll show it to you in the textbook. But let us first see another function which is common, which is INDRCT, indirect. Again, we know that here, if your most significant bit of DR is 0, it is a direct addressing mode, and if it is 1, it would be an indirect addressing mode. So what to be done if your most significant bit is indirect? Okay, so here we will also make a function that would check the indirect bit I, and if I is 1, what we need to do is, we need to do M of AR to AR again. Okay, so what we will do is, we will again carry out read operation, read U jump next, and What would be the origin of this indirect? Fetch is starting from 64. So 64, 65, 66. These three locations are occupied by fetch. So indirect will start from 67. So what will we write over here? ORG 67. So your indirect microprogram would start from location 67. In this, what we need to do is, do you remember what do we do when if your indirect bit is 1? M of AR to AR. ऐसा करते थे हम. Now, how to write M of AR to AR here? I cannot transfer M of AR to AR directly. So what we will do is M of AR to DR and then DR to AR. We will write these two steps in the form of a program. So what will this function do? Read micro operation do? Read will transfer the contents of M of AR to DR. Once I have the value in DR, what will be the next step? DR to AR. DR TAR. Okay, DR to AR. And then what you will do is U and return. So what did we do? We made a micro program here. It is like a function. We made a subroutine. What will this subroutine do? If my indirect bit is 1, it will carry out M of AR to AR. और ये हम तभी कॉल करेंगे if your I bit is 1. So this is what? This is just for, this is a function which is to be called and returned. इसलिए हमने इधर क्या लिखा? Return लिखा. कि if your I is 1, your program execution would jump to this location. After executing these two lines, it will again go back to your original program. Okay, so these two functions clear, fetch and indirect, because this would be used in all our remaining microprograms. Fine. Chalo, now let us move to the next one and see all the other. मैंने आपको कहा कि we will be seeing add, branch, store and exchange. We are going to see these 4 instructions and we'll learn how to write microprograms for all of these. Okay, so now first of all, opcode for add is 0000. For branch it is 0001. For store it is this, and for exchange is 0011. Okay, what will happen in add? In add, what we will do is we will add the content of AC and memory word. EA stands for effective address. So add the content of AC and memory word and store it to AC. What will we do in branch? If AC is less than 0, अगर AC negative है, then PC equals to effective address. We'll be writing programs for all these, okay? But first you understand what are we going to do in this. In branch, if AC is less than 0, that is if AC is negative, then PC equals to effective address. In store, whatever is in AC, we will store it to the memory. And in exchange, we will exchange the content of AC and memory word. Chalo, fine. So these 4, we'll be writing microprograms for all 4 of these. Okay, so starting with the first one. We all know how do we start writing a program? From origin. Okay, what would be the origin of add? How to calculate origin? Whatever opcode is given to you, append 2 zeros over here and 1 over here, because for this configuration which we are studying, in that each instruction occupies 4 control words. Okay, so we appended 2 zeros here and 1 over here. This is my opcode. So this resulted into 0. So where would be the microprogram for add in your control memory? At location 0. Now the next step is make the label add. Now to perform add, I will first have to fetch the effective address, and I should first check if it is indirect bit, my effective address would be different. If it would be direct bit, my effective address would be different. अगर मेरी direct bit है यहाँ पे, direct addressing mode है, तो whatever is written over here is your effective address. And if this is 1, you will be going to this location और उस location पे जो भी है, that is your effective address. Okay, so first of all I need to check whether this is my direct or indirect addressing mode. Okay, so here first thing is whenever memory is involved, आपको memory से कुछ fetch करवाना है तो हमेशा first of all check whether it is direct addressing mode or indirect addressing mode. So in whichever operations memory is needed, what would be your first step? Check the I bit. तो पहले कुछ मत करो, that is no operation. Then check I. I is the condition. CD में हमने क्या लिखा? I. No operation. I call. If I is 1, call, किसको call करना है मुझे? The function which I just made, indirect. So what would be the first line in add? No operation, I call indirect. So if I is 1, indirect में जाएगा, indirect में जाके effective address को AR में डाल देगा. Okay? Now what would be the next step? Now I have the effective address. So now what will I do? I'll fetch that particular operand from memory. So for doing that, what would be the next micro instruction? Read. Read will fetch M of AR into DR. So read U jump next. Okay, we are just writing this in sequence. Read करवाने के बाद, what is the next step? Now I have my M of AR into DR. आपको क्या करना है? AC और memory word का addition करना है. So in the first step, what did we do? We found the effective address. In the second step, what did we do? We fetch this M of EA to DR. And in the third step, what we will do? AC equals to AC plus DR. Okay, simply addition. Now we already have a add micro operation present in our which pool? F1 pool, I guess. No, sorry. In our yes, F1 pool. In F1 pool, we have add micro operation available. So I will simply write add over here. As soon as I write add, मेरा काम खत्म हो गया. So simply what you will do is you jump fetch. What does this mean? Jump to fetch the next instruction. So add का microprogram हो गया. Okay, the first step was finding the effective address, then reading the operand and storing it to DR. And the third step is addition of that. And this is the microprogram for add. Similarly, let us see how to write the microprogram, next microprogram. Next microprogram is for branch. In branch, what do we need to do is, we need to check if AC is less than 0, if AC is negative, then only branch. Okay, and how can we branch? Simply store the effective address to PC. So if AC is less than 0, then carry out branching. Now, we know that the opcode for branch given over here is 0001. So what would be my origin? Origin would be, पीछे 2 0 लगाओ, आगे एक 0. So what is this? 4. So origin would be 4. Then start writing the microprogram. Branch. Okay. Now, here, first of all, I need to check if AC is 0, तभी मुझे memory का access करना है, effective address. So here I'll not write my first statement to be no operation I call indirect. I want to check whether direct indirect mode memory से effective address fetch करवाना only if AC is less than 0. So what is the first thing we will check over here? We will check the sign bit. If your sign bit is 1, the number is negative. Okay, so here what would be my first step? No operation S jump. अब अगर साइन बिट 1 है तो मुझे कुछ करना है, बट अगर S 0 है, if the value of S is 0, automatically it will go to the next step. But if S is 1, then this branching would take place. तो हम क्या करते हैं? What we will do is, first of all, let us write for S 0. अगर S negative नहीं, if your S is positive, what I need to do is, I don't need to do anything. Simply no operation, you jump fetch. Go and fetch the next instruction. मुझे कुछ नहीं करना है. ठीक है? So we know that if S is 0, it will automatically go to the next line. So I did not complete this line right now. But if S is 1, jump to this location. तो इसको हम नाम दे देते हैं, अभी एक label बना देते हैं इधर, over. I'll make a label called over. You can make any label. It can be L1, L2, L3, any label. So if S is 1, jump to over. ठीक है? तो अगर S 1 है, तो jump to this location. And if S is 0, by default, it would go to the next line. That's why I kept this empty. ठीक है, आपको समझाने के लिए. अगर S 0 है तो next line, तो मैंने next line पहले लिख दी. Next line, what would this line do? No operation, you jump fetch. It will directly jump to the fetch the next instruction. Okay, and afterwards, in over what we will do? अब मुझे पता चल गया है कि my AC is negative, so I need to fetch the effective address. To fetch the effective address, I'll need to first check whether it is direct addressing mode or indirect addressing mode. Okay, so in over, what we will do? We will write our first statement as no operation, I call indirect. And once I get my effective address, I'll write the read operation. ठीक है? नहीं, इसमें read नहीं करना. In this, after you fetch the effective address, you simply have to store that effective address to your PC. Why am I not able to delete it? Okay, so after this, after you get the effective address, you simply have to store it to PC. Where would this effective address be? In your PC. This effective address would be in AR. So what would be the next step? AR to PC. You jump fetch. AR to PC would transfer the content of your AR, जो भी effective address AR में fetch होके आया था, it would be transferring it to PC and hence my branch is done. So these 4 micro instructions are for your branch microprogram. Any doubt in this? Okay. What's happening? I don't know. Just a minute. Okay. Now let us move on to the next one. Next is store. Opcode is 0010. If opcode is 0010, what would be the origin? 8. Okay. In store, what we will be doing is whatever is the content of AC, store it to memory. So here, again, I want to find the effective address. So what would be the first line? No operation, I call indirect. Then I will be getting the effective address. So the next step would be AC to DR. You jump. Now why did I do AC to DR? Because मुझे क्या करना है? I want to, whatever is the content of AC, I want to store it to memory word. हमें EA मिल गया through this statement, but can I transfer the content of AC directly to memory? No. Memory can, whatever I want to transfer, I can transfer it only by transferring to DR, because memory has direct connection to only DR, no other registers. Okay, so first what did we do? We transferred the content of AC to DR, and in the next step, we will be writing this content of DR to memory. So in the next step, what we will do? We will call the write micro operation. So write micro operation, you jump fetch. Go and fetch the next instruction. Write से मेरा काम खत्म हो गया. Okay, so this is store. Next comes exchange. Let us see the microprogram for exchange. Again, its opcode is 0011. Okay, so what would be the origin? 12. ORG 12. 8400. So 12. Okay, ORG 12. In exchange, what we need to do is, first of all, again, we are going to exchange the content of memory word and AC. So मुझे effective address चाहिए, तो सबसे पहला step क्या होगा? No operation, I call indirect. Okay. Then whatever is in the memory, fetch it to DR. DR में fetch कैसे करेंगे? Through read, you jump, next. Read हो गया, DR में value आ गई. अब क्या करेंगे? Can I do this simultaneously? AC to DR, DR to AC. Both of them are in different pools. So two micro operations together. I swapped the value of AR and DC. You jump next. अब मेरी जो भी AC की value है, that is in DR. But I want that to be stored in memory. So what we will do? We'll write the write micro operation. You jump fetch. Okay, so this is for exchange. हमने क्या किया? First of all, we fetched the operand from memory and stored it to DR. इन दोनों के स्वैपिंग को हमने carried out in this micro instruction. Both of these are in different pools f1, f2. So they can be written together. And then once my values are swapped between AC and DR, whatever is in DR के अंदर AC की पुरानी value होगी. So whatever is in DR, we will be writing it back to memory, and hence my exchange task is done. Right? So this is how microprograms are written. Same thing can be written into binary. Just hold on, I will show it to you. We will not write binary for all, but you can convert it into microprograms. You can convert it to binary microprogram on your own if you know the binary value of each and every F1, F2, F3 field and CD and BR. CD, BR you have to remember. 0, 0, 0, 1, 1, 0, 1, 1, 0, 0 is U, then I, then S and Z. Z. That is for CD. And for BR, 0, 0 is jump, 0, 1 call, 1, 0 return, and 1, 1 map. Okay, let me open that binary microprogram. Just hold on for a minute.